So let's begin. My name is Sergey Mashukov. This talk is called Creating a Fuzzer for Telecom Protocol 4G LTE Case Study. So, as been said, work for Positive Technologies. Usually we do audits for mobile network operators all around the globe, and we also create products to protect their networks. So I perform the audits in my area of expertise, and my area of expertise is diameter protocol, and to be more precise, its use as a signaling protocol in the 4G networks. So what do I mean when I say signaling protocols? You have when you're talking mobile networks, you have two types of messages. First, user messages, like your usual calls, your data, and messages that are needed to set this up, to connect to users, to set up data path, and that's signaling. And that's interesting for many, many reasons. Well, here they are. On this slide, you can see results of work on SS7 protocol, signaling system number 7, protocol suite. It was created in the 70s, and it shows. It wasn't really looked deep into until like 2014. But since then, we have a lot of issues discovered, like disclosure of identifiers, and that allows malefactor to get your location down to the cell, to deny the service for any subscriber. So basically, no phone coverage, no calls, no SMS, no nothing. And what's especially bad is SMS interception and spoofing. You see, nowadays everything is connected to SMS. So if you want to register Telegram or WhatsApp, if you have your Bitcoin wallet, something like that, it all goes to your mail. And to do something with the mail, you can use SMS. If you can intercept SMS, you can do a lot. Actually, there have been two different cases where banking fraud was done using SS7. So malefactors first got like mobile banking passwords, things like that, and then they intercepted SMS and drained their accounts. So two cases already of this in the wild. And also call interception, actually you can do it in a way that you intercept the call and route it back to the guy you had to talk with, so you can listen what's happening and it will be discreet. So, okay, that's S7, that's 2G, 3G technology. In 4G it should be better, right? Well, not necessarily. Diameter is used in 4G and 5G non-standalone until a new network core is created. And it has the same groups of issues. Problems with interception of SMS, with tracking of subscribers, denial of service on network equipment, and fraud. But since we are talking about fuzzing, now in most cases we will see some problems with denial of service on network equipment. That's what we get via fuzzing anyway. So what should I also say about diameter? It wasn't created specifically for mobile networks or any other telephone networks. it is actually a work on a protocol called Radius. You see, it has some flaws. It wasn't really extensible, and guys decided, let's do Radius plus Radius diameter. And it's much better in this field, but it wasn't created specifically for mobile networks, and it has its own quirks that are not really suitable for such networks. For example, it really is spoofing friendly. So you can send a request, and answer will go the same way request came. So you can spoof anyone and still have the answer, and that's what enables like location disclosure in many cases. So as I said, it's session layer authentication, authorization and accounting protocol. It's clear text. It works over IP because that's what 3GPP needed for LTE, which is all IP. It supports SCTP or TCP, but SCTP is used in telecom context almost always. Interestingly enough, it has IPsec or TLS, DTLS for encryption as a mandatory part. And to be honest, I've never seen IPsec used inside of the operator networks. So, okay, it is mandatory, but it's not used. It may be used between operators or between interoperator or in interoperator network, but that's what we get. And again, it's extensible. It has like one RFC with the interbase, handling connection between peers, disconnection, watchdogs, things like that. And you have applications on top of it, all kind of applications, but we are most interested in ones created by 3GPP. So again, extensibility is kind of weak part of the emitter just because any part of the message and any message has this part in definition where, okay, it's a message, here information elements that you include there, and here is any number of any information elements that you can add. The same for the information elements themselves if they contain other information elements. So basically you can add anything by the protocol. You can combat these. This is done specifically for extensibility. Yes, MNOs can do something with it, can do checks, but this is done to have new version of protocols without doing changes on all the ones. So it works. There are no interworking problems. So here you can see the enter header. You have your version, which haven't changed since the beginning. You have message length, comment flags, like either request or answer, or either sent due to an error. You have common code, basically which message it is. You have application ID on which application. You have some identifiers that are needed for routing. And then after this header, you have a number of AVPs, attribute value pairs. And those have their own code, their flags, lengths, and notice this, the single optional field in headers, vendor ID. So if VBit is set, this one is should be there, and if it's not, it should not be. Then you have the data, many different kinds of data possible. Usually it's like strings, or for example, integers of different kinds, but also AVPs can contain other AVPs. So you have nested structure, and it may also be used in fuzzing. So that's what we have as basic message structure for fuzzing, and that's what we need to know to start doing it. Let's see where it is used now in 4G and LTE. Well, basically everything in red is diameter. So you have your user data path and you have signaling in the core. And most important, most interesting nodes for malefactor here are HSS, home subscriber server, containing all the information about subscriber, and MME, mobility management entity, which basically governs mobility of user. Node B's base stations are connected to MMEs. Usually there are like 2 or 3 MMEs in the major cities, things like that. So why this is interesting? Because this interface, S6A interface that connects them, should be accessible in the between operators in the inter-operator network. Because if you roam in Singapore, for example, or in any other country, you need to connect to the base station, and then you need to connect to MME in that country. But all your data, all your keys, everything is stored in HSS in your home country. So this part is over some interoperator network, right? So with this out of the way, let's talk about fuzzing. So you can read definition in Wikipedia, but you can also see what this means in Wireshark. Here you can see AVP code 1, unknown for some reason. AVP code 1 is username. In 3GPP in mobile system, it's usually IMSI of subscriber. But for some reason, vendor ID is unknown. And yeah, it is unknown because I've set to some strange value. And that's what you get in the fuzzing. You get some parts altered. So if you read the description, there are 2 things that you really need. You need software to perform the testing, and you also need a way to check and interpret the results. You may have best software there is. If you can't see the results, it's meaningless. And why am I talking about that? Because you see, usually it's MNOs that approach us to do the testing, not vendors. So, okay, we are doing this on MNO side, but my belief is that normally this should be done by the vendors. And it's done by the vendors, actually. If you check my bio, you've seen that I worked for one for quite some time. And yeah, we had a Fuzzer board. It was specifically created Telecom Fuzzer. Everything is okay. But there is a slight problem with these. Problems that were found during fuzzing were not top priority, like not top priority at all. So yeah, they were fixed, but it was a chore for the developers, and it was usually like the last thing they did. There's also this big problem of walled garden in the telecom industry, where there is no access to hardware or code. Okay, some researchers might have access. There are partnerships between MNOs and researchers, but again, MNOs, not vendors. And result is there are bugs in the code. And in practice, we found that more than half of tested equipment has some vulnerabilities. If we count each single node, it's about like 2/3 of them has something. But you need to understand this thing. While bugs may lead to serious consequences, it's not every bug is a security issue. So we are dealing with these big telecom clusters. Okay, you've sent malicious output. You see the crash in the logs. Fine, but what is the actual result for MNO? What is the actual result for the subscriber? Because usually this process will be restarted on another processor. Nothing happens. So you need to really check what's happening in the system. But talking about bugs and fuzzing, another thing, everyone says, okay, fuzzing is malformed. Yes and no. Sometimes even correctly formed messages may cause the same results, which was the case for Telenor, quite large operator. They had outage for like 3.5 hours, and I guess they had a lot of fines after that. More than 1 million subscribers was affected, no service at all. And the reason for that is testing in some other network. The messages were sent by mistake to their network, and the HLR, basically the same database as HSS in 2G, 3G, just went down, and it was rebooting cyclically in a cycle. So, okay, could they find this by fuzzing? Possibly, but they didn't. Vendors didn't do their job. And also, since we are talking about process crashes, there's also an option of finding RCE on the hosts, and it's quite scary. Some security researchers showed that it is possible, but for real malefactor, it's kind of hard to do, because it's kind of hard to get the binary, for example. Everything in the network, all you do is through the network. But again, if this is successful, you can take over one of the nodes and then use these to spy on other subscribers or bring down the whole network. So, as I said, there are 3 different ways to test. You can do this in vendor's lab, you can do in operator's lab, or in a live network. And what we usually do is operator's lab, not vendor's lab, unfortunately. Okay, there's option of live network, but as you've seen with Telenor case, it might be not the brightest idea to do fuzzing there. However, you should always remember that test lab is usually so much different from the actual network that you need to actively ask MNOs to change something. Usually non-standard identifiers used. Routing is different because usually in their networks they have like a single node and its connection, and they don't create the whole core in the test lab. Maybe they do this sometimes, but usually they do test on a single node, and this works quite different. So fuzzing and found problems. There is a recent case where guys tried to do fuzzing from the base station side. There's no diameter here, so that's not what interesting for me, but this shows that there are plenty of fish in the sea. You can find a lot of fishes. And again, guys from Korea Advanced Institute of Science and Technology case, they created their own fuzzer for that. It's not that hard to do. So, 2 things to note. Again, problems may be overlooked, and you also need to keep in mind that not all problems that you find during fuzzing may be exploitable in the wild. So how we can use diameter realistically, how malefactor rather can use diameter realistically. Most probably IPX network should be used for that. IPX is a network between all the operators in the world. So if you have connection to it, you have connection to any operator. And the scary part is that you can buy access to IPX right now. We have our own access for our audit service, and if we as a company have it, I don't see why any other company or individual can buy it. One more thing to note though, with diameter and DA, it also means that your targets like HSS and MME are behind this DEA. So you need to send the message first to DEA, and then it will be routed. And many malicious messages will not go through, just because parser on the DEA will say, okay, that's something strange is happening, and drop the message. So you need to check for that as well. So as I said, DEA diameter H agent is router. One interesting thing about it, it can route internal traffic. And due to this, it may present a single point of failure where disabling DEA itself leads to the whole network being unresponsive because there's no connection between internal MMEs and HSS, for example. So yeah, our practice shows that there are some problems with DEA, and one of them is that DEAs of some vendor just plainly ignore configuration. In this case, DEA was supporting only S6A as it should when connected to this IPX network, but for some reason it sent it routed any message that is supported inside the operator's network. I actually changed the messages just to not show actual issues because I'm not quite sure that it's still fixed. Why this may be a problem? Well, because you can attack HSS, and yes, we did find an attack that can drop diameter connection between DA and HSS. Malefactor needs to send a burst of messages for this, and we actually checked, can we do this through DA, because that's malformed, right? And yeah, we can do this, and this means that we can, malefactor can use this through the IPX. The problem for malefactor is that not all intermediaries in IPX will route this CX message, so you need some luck to send message to the DA which is not S6A. So, okay, my mind is set. I want to create, I want to fuzz my MNO network, for example. What do I need for that? I need a fuzzer. Why do I need a separate fuzzer for that? First, why can't I use existing technology? First of all, you need to communicate through the network. And for this, you need like working diameter stack, usually. You have specific structure, and if you just fuzz message without regards to the structure, most of your fuzzing will go to waste. And of course, one upside of creating your own fuzzer, you can adapt it to whatever problems you have on site. Also, I might say that if money is a concern for you and you don't want to buy like expensive fuzzer for something that you do not so often, it's quite easy to create one if you can program a little bit. That's why do we need fuzzers. Now, I can use existing protocol implementations, right? Well, usually not. And the problems come with creating malformed messages because these implementations are programmed to create correctly formed messages in correct order. And usually there are some problems with when you are dealing with database level, like connection establishment, answers. If you need to test those, you need to have your own implementation, or at least the one that supports like sending arbitrary messages on in response to arbitrary messages. There are also several points about the diameter protocol. There are two kinds of messages there. Wrong from encoding perspective, like this wrong AVP, which has very long length for some reason, or wrong from semantics perspective. For example, insert subscriber data message should have only one username identity. There are 3 of those in this message, and that's also a problem. So to do the testing, you need messages that are somewhat similar to real ones, and for this, you can ask operator to provide these messages. And one thing to always remember, it's not enough to say, okay, it crashed. You need to isolate the problem. Our solution to this is good old mutational fuzzing. So one thing to note is that you would need not only messages, but messages filled with correct identities. So usually you prepare your messages before sending them. So what kind of mutations we used? We used random bit flips in headers, and we used preset values. For random bit flips, it may be like going through all the bits at once, and then flipping all bits at random several times. When we are working with AVP values, since AVPs may be of different length, you can do random appends removals. And you also may change structure of AVPs, like with this several username AVPs there. And yeah, surprisingly, such simple fuzzer works on real equipment. Here we tested MME, and it's really interesting problem, because, as I said, when you send malformed message to the node, it's a big cluster, a lot of processes, process crash, it goes up, everything back to normal. The problem here is that if you persist in sending these malformed messages, and you don't need a lot of time, it's like 2 or 3 seconds and burst of like 100 to 500 maybe messages, the node will escalate the problem. So it was created for upgrades and things like that, probably. So when something goes wrong during upgrade, the node will reboot first process, then processor, higher, until the whole node reboots. So in this case, a recovery mechanism works against the security. And the reason for the issue is this V bit, which has been set for some AVPs, which shouldn't have it set. So probably that led to a parser trying to read more bits than it should, and here we go. process crash. So now I'm going to talk about several interesting parts that I've seen while creating the Fuzzer. And one of them is actually dealing with MNOs, because you have to adapt the Fuzzer for MNO, because test lab for some reason may be connected to international network. And again, you don't want to do something like what happened with Telenor. The other problem is purely on administrative levels. Test lab is always booked. It is always used for other tests. And well, you come with the security guys, they say, okay, we are gonna do fuzzing, everything will be all right. And guys handling the labs just say, no, we can't give you the node. No, you have to work tonight. No, we have tests, please don't touch anything. So solution for that is blacklisting some of the values. This allows to perform tests at the same time as test lab is used in usual tests. And sometimes it helps, sometimes it not, but you have to do this. So what are other problems implementing the Fuzzer? There is a problem with exhaustive testing, because sometimes operator needs you to test everything. They think for some reason that it is possible to do, and it's not. So solution to this is to fuzz faster. And to do this, you really need to study protocol you are fuzzing. In diameter, there are two kinds of mutations that affect length of the message and that don't do this. And actually, you can get away with changing the length only for the ones, like for the strings, for the ones that are not aligned to 4 bytes, that don't have fixed length. And this means that you can encode your message first and then fuzz it, which is quite faster than re-encoding it all the time. The other interesting topic is mutations in length. I think this part best done after you do all your scope, like you do the length mutations during its own scope. And again, there are questions how to do this, because you can update all headers in the message appropriately, or you can also don't update them. You just go and put some wrong number there. And I think you should do both. So speaking of problems with length, we've seen this issue where there is a nested AVP in vendor-specific application ID, vendor ID and auth application ID. And if you set AVP length to 0 in parent AVP, DA crashes, and it affects service on for the other users as well. Other thing that everybody who sells fuzzers for like diameter for telecom protocols tells is that you need stateful checks. Stateful checks is a must. But actually, when do you need to go stateful? When you are testing state machines. And since in diameter, most of the applications don't really use these deep state machines. They just like request an answer. You don't need that. And again, we haven't implemented these yet and found a lot of problems. Other issue is actually connected to your own tools. You can send a formed message to the node. The problem is node will answer, and in Diameter it will answer with failed AVP. And in this failed AVP, you will receive your malformed answer. So you better be prepared to receive your your own malformed messages. And this is a problem because sometimes you need to pass the messages and sometimes not. So you need this configurable. Again, you need to create your tools so you're prepared for that. Then the other problem with handling connections and sessions. While most of protocols are just request and answer, some of them would need you to start connection on or even session first. And if you test certain nodes and certain application IDs, this means that you need node to send you a message. And for this, you need some emulator, some changes on the node. Again, you need to talk with MNO beforehand about that. You also don't want to break the connection during fuzzing because of all the reestablishments and all the lost time. And that's true for any protocol, not only for Diameter. In the Diameter, you better bar changes in message type where it can be changed to disconnect peer request. So, but you still should test that, of course. Just test them in a separate scope. So, as I said, in some cases, you would need emulators, and a good rule of thumb to have your own, because yes, you can ask MNO, but in most cases they say no. Also, quite a simple thing, but well, Captain Obvious to the rescue, you need to update identities that should be changed between each message, like you need to update hop by hop and end-to-end identities for Diameter. Okay, you've created your fuzzer, nice. Then comes hard part. You need to understand what's happening. And for this, you really need logging in your fuzzer. Log everything you can. And this really helps, may I say. So you are at mercy of network elements on monitoring systems. Usually it goes like this. MNO guys say, okay, please use this IP. Here's a system you are seeing for the first time. But sometimes it goes even funnier than that. In one case, they just said, here's SSH to the node with binaries of a vendor. I don't know why they did that. So, and do console commands. Enjoy. And you are on your own from now on. You can ask them for help, but they don't really want to spend a lot of time with you. So, what I said, the hard part, reproducing the issues. You need to keep an eye on system time on different nodes because often that's a huge problem in the lab. And I mean, not like different time zones. Sometimes it goes a certain minutes and seconds one after another, so that's a problem. A bright idea would be to save the random seed that you used. And while it might be a bright idea for the reproduction, in some cases where you like spent an hour or more doing the same tests and then it crashed, it might be better to reproduce with different random seed just to get the same issue faster. Again, in my case, I work with MNOs. I always need to like file a report, and it's not enough to say something crashed, and that's what you want to say when you have fuzzing, because it's really hard to understand what the problem is. And to get working proof of concept, you really need to think about what message you should send to crash the system. For diameter, this usually boils down to changing AVP content, and before changing AVP content, understanding which mutations help. Which was the case with this problem, actually. We reproduced that when we did random change in message structure. Okay, it boiled down, so this mutation helps. Okay, it's time to slow the things down, because usually you have like thousands, hundreds, tens of messages a second. It's hard to understand which one of them really triggered the issue. So the first thing you do, let's have the same random seed, right? And try to slow. No, it's not reproducible in this case. So what really helped is narrowing down types of mutations, then AVP content, and it allows us to have this really small message that triggers all the time. Surprisingly, in this case, we needed the burst of messages for it to even crash, but once it crashed, but once you understand that, you see that it's reproducible, always, just the burst of messages. So, a few words about your typical project with MNO. You've got initial contact from them, they say, we need this fast, like, we are going to do this. Then you have several months of back and forth, sometimes a half a year, sometimes a year. And then it comes to the moment when they say, get started next week. You need to do this now. Okay, you pack your backpack, you go on site, and on site there are always some issues, always something happens. Rather typhoon, public holidays, not being communicated. Well, real story, we had like the plan for the project and everything, and our partners for some reason didn't bother to tell us, okay, we have public holidays, so lab would be unavailable on one of the days. And sometimes tests just can't be done in the lab for some reason that is not communicated beforehand. As a result, almost always time for test is shortened, and it is not possible to do additional tests. So again, if you are onto something, don't say, okay, I have my scope, I will test this later. No, you need to get work in POC as fast as possible. You may not, you may have some problems, you may don't have any other chance to do this. Again, you need to ask for access to log systems beforehand, and usually that's a tough part, because you ask one time, you ask several times, you ask on site, it takes time. In one of the cases, I spent like a week and a half just waiting to have my connection to the node be configured. So if you can get access to vendors, representatives, they can shed some light on what is happening on the node really. Because, okay, you see the alarm, it's like module fault or capsule abortion. It doesn't say much for you. You need to understand what is the actual result, how it affects the system. Of course, have enough time planned for investigation, but as I said, most probably, even if you have it planned, you still have some issues. And it's better to have larger scopes and go in depth with one message in most cases. don't forget to present your results comprehensively. Usually the guys are reading these are both executives that don't understand what's happening at all, and you need to put it in a simple terms. And of course, security officers, they do understand, and for them you need like detailed descriptions. Working POC in our case. Again, for evaluation, go to vendor representatives. So that's the end of the talk. Few key takeaways. First of all, decide if you need your own protocol implementation. Don't forget to adapt your fuzzer to the operating conditions. How we did it for MNO, it may be different for you. Study the protocol to see when you can speed up the work. Check first if you need stateful checks at all. Maybe you can do everything in your lab quite easily. Don't break the connection. Pass answers when it's appropriate. Create your own testing programs that will help you. Plan beforehand, include flash factor, log everything, and most importantly, always try to report your findings in a comprehensive way, because once you start writing the report, you always have additional thoughts. Maybe I should have tested this, maybe I should have tested that. So it's better to start as early as possible. So thanks for your attention.
Thank you, Sergey. We're now ready for questions. I see Altaf's hands up. All right. We'll do the live questions first then. Over to you.
By the way, there are some goodies for questions.
Okay. Yep. Are you aware of like MNOs using honeypots on the IPX? That's my first question. And then the second one is,
yes.
Is the result of fuzzing always a crash? Or sometimes like when you use reserved values or like unused values, does it invoke a different procedure? Like, for example, like sending some location update or something like this instead of a crash. Yeah.
I got it. Regarding MNOs, actually, what we see when we are implementing our products, MNOs don't have a clear understanding what's happening on the IPX. Like they have misconfigurations that have traffic that comes for no apparent reason, and they don't know this. I really doubt that they have honeypots. Maybe the better ones do. The problem is that each MNO is different. You have some that are 4G only, top-notch security, and ones that don't do anything and thinking how to have CapEx and OpEx as low as possible. And the second question, is it always a crash? Well, it doesn't necessarily always a crash. The problem is how you understand that. Again, as I said, in MNO case, you don't have access to systems in a comprehensive way. They give you like, okay, this is our fault management system. You see it first time. And it doesn't log for memory leaks, for example. And that's why I'm saying you need to go to vendors to really fix everything. But usually what you see during the tests is crash. So that's more about what you see, not what's happening with the system, you see?
Thanks.
Any more questions from the floor? I have to say, Sergey's gifts for questions is the best gifts that speakers have brought this year. So if you, I would raise hands for good questions. Anyone else? Oh, well, okay. You're in the count.
I know how companies get it, but for an individual, like a researcher or some enthusiast?
Usually you need to be a company. The thing is, nothing stops you of being a company. That's the problem. So you can say, okay, we have like weather forecast solution. We need to send SMS. Can you do something for us? And well, yeah, they can.
One more question, one more live question, Mark?
Sure.
It's more of a light-hearted question, but do you know why they called it diameter?
2 radiuses?
No, because it's supposed to be twice as good as radius.
Well, it's supposed to be twice as good. The thing is, maybe it is twice as good or even a lot better than radius in its original field, but for telecom, for signaling, I don't think.
All right, well, now to the Slido, the highest voted question at the top.
You see, that's, I think I maybe forgot to mention, we don't do this often, and we don't really think that that's the work that we need to do with MNOs. Okay, sometimes they have, like, how should I put it? Someone come first and they and say, okay, we fast your network, here are results, and they need this redone several years later, or they have their own brand new vision on what fuzzing should look like. Sometimes they need fuzzing results. It feels like just to bargain with vendors, just to say them, aha, you have problems, so what about price? And since we are not doing this all the time, we did the simplest one we could, mutational one. And that's why we haven't considered generational fuzzer at all. It was just clear for us that it's the way to go.
Before we move on to that one, may I know who asked that question? All right, we'll pass you your gift in a minute. It's over here. Altaf, Altaf and Mark for the live question. And the next question?
Okay, instrumentation. I don't really understand what kind of instrumentation you are referring to. Again, I'm talking about case where you have just IP access to the node and IP access to fault management system. That's all you've got. Maybe you can do with other tools, but that's it. You can go and, for example, for diameter, it's really easy. You can go and download like Python package. That's easy. Then go and download Python bindings to Linux kernel SCTP. Then go and find somewhere in the internet, you may ask me, I know several, implementation for Python, for diameter. You may go through it. Actually, that's how I started. I had to rewrite it because it has a lot of problems internally with sending malformed messages, but still you can start with it. And just then open technical specification, create a message, and try to fuzz it. It really is simple. It doesn't take any money to start. All you need is skill and like a week of work. That's it. And actually, that's the message of the talk. You don't need to buy these overpriced fuzzers to find actual problems in telecom network. You just need to, if you are in the MNO, you just need to start doing it. It's easy.
Next one. Or choose whichever question you'd like.
Sometimes, is there any way as a user to detect if I'm a target of telecom attack? Sometimes yes, sometimes no. In some cases, you will see, believe me, for 4G attacks that I'm doing, you'll see like flashing connection, flashing network symbol on your phone. One of the attacks is about sending like update locations, like doing DOS once a second, and you will see that. But if someone tracking your location, I'm afraid no, you can't be sure about that. It's what MNOs need to handle. And they try actually. There is this whole GSMA association that works on the ways how to deal with that. Have you looked into these attacks on 5G networks, or if they will be fixed when 5G comes out? Again, this boils down on what you understand as 5G. In 5G standalone, there won't be any diameter. The problem is that they most likely will still use the same procedures. And that's the problem. You have the same procedures with the same tests. Vendors won't do any security updates on them. They just like, okay, I do the same thing, but in other protocol. No checks, no nothing. And there is a risk in 5G standalone with new protocols that this still be the case, but actually they're working on the security. And when we are talking about non-standalone version, it's the same core network. There's no difference. So if someone says to you right now that they have 5G network, they have non-standalone. And this means that all these attacks are possible. How much fuzzing is required for robustness level? I kind of don't get the question. Yes. Yeah.
I just want to ask the way to stop.
Where to stop?
Yep.
In most cases, it's not a question. The question is how to get more time with the node. You see, usually if you are reproducing, it's like you actively monitor log system and you see, okay, it crashed, I need to stop. You have everything recorded, but more often than not, you need to alter the message to understand what's happening. Even if you have the logs, it gives like this understanding, what was I doing? Like I was fuzzing left. I was changing this AVP in this place. So you may then work only on this AVP, for example. Some MNOs actually asked us if it is possible to send a message to check if everything is working fine, but I don't think that works like that. If you send correct message, you get correct result by maybe different process. That's not how you do it. So basically, it's all down to monitoring FM.
Okay.
I think the last two questions probably can answer together.
Other providers allowing fuzzing in their networks. There is a GSMA document about fuzzing by independent researchers. We usually have like agreement with provider. We go on site for this, and we do fuzzing in the test lab. Fuzzing in the real network. To do this properly, you need to connect to operator, and I'm quite sure that they will say no, and I don't think you should really do that, because, okay, you fast MME or HSS, now the whole city is without network. In countries like Korea is without any mobile network for these operators. That's a huge problem that can get you in a jail, I think, in some countries. And the last one, yes, the findings of the fuzzing are usually vendor specific.
All right, that covers it. Any more questions from the floor? No? Sergey, your vote on who was the best question from the floor that you would like to award your cool gifts to?
I got two goodies, and they go to guys in the back.
All right, Altaf and the other gentleman?
Yes.
All right, come on up. Come on over. Yeah, we'll just get these gifts. Thank you, Sergey, and thank you to all the audience for participating in the question.
Good question, guys. RFIDs. Pen,
Yeah, it's a
with
cool
USB
one, right?
stick.
Thank you. And thank you very much again, Sergey, for a really cool, engaging talk, and to all the audience for participating. Thank you very much.
Thank you.